A pulverized coal-fired boiler is an industrial or utility boiler that generates thermal energy by burning pulverized coal that is blown into the firebox. The basic idea of a firing system using pulverized fuel is to use the whole volume of the furnace for the combustion of solid fuels. Coal is ground to the size of a fine grain, mixed with air and burned in the flue gas flow. Biomass and other materials can also be added to the mixture. Coal contains mineral matter which is converted to ash during combustion. The ash is removed as bottom ash and fly ash. The bottom ash is removed at the furnace bottom. This type of boiler dominates the electric power industry, providing steam to drive large turbines. Pulverized coal provides the thermal energy which produces about 50% of the world's electric supply. History: prior to the developments leading to the use of pulverized coal, most boilers utilized grate firing where the fuel was mechanically distributed onto a moving grate at the bottom of the firebox in a partially crushed gravel-like form. Air for combustion was blown upward through the grate carrying the lighter ash and smaller particles of unburned coal up with it, some of which would adhere to the sides of the firebox. In 1918 the Milwaukee Electric Railway and Light Company, later Wisconsin Electric, conducted tests in the use of pulverized coal at its Oneida Street power plant. These experiments helped Frederick L. Dornbrook to develop methods of controlling the pulverized coal's tarry ash residues with boiler feed water tube jackets that served to reduce the surface temperature of the firebox walls and allowed the ash deposits be easily removed. This plant became the first central power station in the United States to use pulverized fuel. The Oneida Street power plant near Milwaukee's City Hall was subsequently decommissioned and renovated in 1987. It is now the site of the Milwaukee Repertory Theater. How it works. The concept of burning coal that has been pulverized into a fine powder stems from the belief that if the coal is made fine enough, it will burn almost as easily and efficiently as a gas. The feeding rate of coal according to the boiler demand and the amount of air available for drying and transporting the pulverized coal fuel is controlled by computers. Pieces of coal are crushed between balls or cylindrical rollers that move between two tracks or races. The raw coal is then fed into the pulverizer along with air heated to about 650 degrees Fahrenheit from the boiler. As the coal gets crushed by the rolling action, the hot air dries it and blows the usable fine coal powder out to be used as fuel. The powdered coal from the pulverizer is directly blown to a burner in the boiler. The burner mixes the powdered coal and the air suspension with additional preheated combustion air and forces it out of a nozzle similar in action to fuel being atomized by a fuel injector in modern cars. Under operating conditions, there is enough heat in the combustion zone to ignite all the incoming fuel. Ash removal equals, there are two methods of ash removal at furnace bottom: dry bottom boiler, wet bottom boiler, also called slag tap. The fly ash is carried away with the flue gas and is separated in various hoppers in the path and finally in an ESP or a bag filter. Current technologies: pulverized coal power plants are broken down into three categories. Subcritical pulverized coal plants, supercritical pulverized coal plants, and ultra-supercritical pulverized coal plants. The primary difference between the three types of pulverized coal boilers are the operating temperatures and pressures. Subcritical plants operate below the critical point of water. Supercritical and ultra-supercritical plants operate above the critical point. As the pressures and temperatures increase, so does the operating efficiency. Subcritical plants are at about 37%. Supercriticals at about 40% and ultra-supercriticals in the 42 to 45% range. Steam locomotives: pulverized coal firing has been used, to a limited extent, in steam locomotives. For example, see Prussian G12. Merchant ships: in 1929 the United States Shipping Board evaluated a pulverized coal boiler on the Mercer, a 9,500-ton merchant ship. According to their report, the Mercer with its pulverized coal boiler ran at 95% efficiency of its best oil fuel journey. It was cheaper to operate and install than ships' boilers using oil as fuel. See also, coal water slurry fuel, fluidized bed combustion, pulverizer. References. External links. Article on pulverized coal power at the World Resources Institute, University of Stuttgart, cyclone furnace.